In today's lesson, we are going to continue with right triangle trig. This time, well, our last lesson was just on finding a missing side length, and now we're going to add in finding a missing angle, fully solving a triangle, and then we're going to look at special right triangles as well. To start, we have to talk about inverse trig functions. So let's say that we have sine of theta, sine of an angle, is equal to a value, x, and this time we want to find the angle. So how do we isolate theta? So just like anytime you're solving an equation, you're using inverse operations. So if we take the inverse sine to the power of -1 like that, of sine theta, whatever you do to one side, you must do to the other side. So the inverse sine of sine, they cancel out, and that right there will isolate your angle. So the angle is inverse sine of whatever's on the other side. And this, of course, will work for the other trig functions. So if you have cosine of theta equals x, then to isolate this, theta will be the inverse cosine of x. And of course, tan of theta equals x. To isolate the angle, theta will equal the inverse tan of x. Okay, so let's do an example. I'll have draw your right triangle. And this side length is 11. And this side length is 26. And we want to find an angle measure here. So let's think about what we have in relationship to this angle. So we have, this is opposite, and then this would be adjacent. So opposite and adjacent in SOHCAHTOA, that is going to be tangent. So tan of your angle is equal to opposite over adjacent. And what we're doing is we're solving for theta. So if we do the inverse tan on both sides, these cancel out and you will isolate the angle. So then you can just type this in your calculator, make sure you're in degree mode, and you will get about 67 degrees. Okay, let's do one more. There's my right angle, triangle. This side length is 5, this one is 12, and we want to find this angle measure right here. Okay, what do we have that's in relationship to the angle? We have adjacent, and then this is across from the right angle, so we have hypotenuse. So adjacent and hypotenuse, that is cosine. Cosine of theta equals 5 over 12. So to isolate this, we'll just take the inverse cosine of 5/12. And when you do that, you will get about 65 degrees. Okay, in this next example, we're going to solve the triangle. Solving the triangle means we need to find all missing side lengths and all missing angles. So for this triangle, I'm going to label this. This is angle A, and directly across from angle A will be side length A. This can be angle B, and directly across there's side length B. The right angle can be C, and across from that will be side length C. So we have a lot of options on where we can start. I'm going to start with this angle. I know this angle, and I know it's a 90 degrees. 90 plus 35 plus angle B, three angles of a triangle have to add up to 180. So then B is going to be 55. And now to find one of our side lengths, we have lots of choices. We could solve for A first or solve for C first, and we could either use the 55 angle or the 35. I'm going to find A first, and I'm going to use the 35-degree angle. So there I have opposite and I have adjacent. So I'm going to use tangent. So tan of 35 equals A over 10. So then A will equal 10 times tan 35, which that equals about 7. So A is about 7. All we have left now is to find C, and we have choices. We can use right triangle trig, or because it's a right triangle and I have two side lengths, you could also do the Pythagorean theorem. Totally doesn't matter. I'll do the Pythagorean theorem for this one. So 10 squared plus 7 squared equals C squared. When you solve that, you will get that C is about 12.2. So I have completely solved the triangle because all three angles and all three sides are solved. Okay, so here is the triangle, and I'm going to call this angle A, which means this will be side length A, angle B, side length B, angle C, side length C. Okay, we need to find all angles, all missing sides. Well, I have two of the sides. To find the third side, I can do Pythagorean theorem again. 8 squared plus 11 squared equals C squared. C is going to equal about 13.6. Okay, let's find an angle measure. Let's find this one. Let's find angle A. So let's do tan. We can really use any of them because we have all three sides. But let's do tan of theta equals opposite 11 over 8, adjacent. So then therefore theta equals the inverse tan of 11/8. And when you do that, you're going to get 53.97. Angle measures, I like to just round to the nearest whole number, so 54. And then we just have one more angle to find. You can do trig to find that angle, or we can also just remember 90 plus 54 plus B has to equal 180. So that angle B will be 36 degrees. And now the last part of this lesson is looking at special right triangles and the relationship that exists with their side lengths. So the first special right triangle is called a 30, 60, 90. So you can probably assume what that means. Here's a right triangle. Here's my 90 degrees. And I have a 30-degree angle and a 60-degree angle. Anytime that we have these three angles, the relationship that exists is x is on the side with the 60 degrees. So if we know that side length, this side length on the bottom will be whatever x is times the square root of 3. And then the hypotenuse will always be 2 times x. So the hypotenuse will always double this side length, and then here we have x times square root of 3. I always, to memorize this, I always would remember that the square root of 3 is always by the 30. And then the hypotenuse is just double the side length by 60. The other special right triangle is a 45, 45, 90 triangle. So let's draw one of those. So here we have 45 degrees, and here we have 45 degrees. So anytime you have those angle measures, the side lengths, well, this is an isosceles triangle, meaning these two side lengths must be equal. And then the hypotenuse is always the leg times the square root of 2. So let's say you're given this triangle, and we want to solve the triangle. Well, if you see 30 degrees, then we know this one has to be 60 degrees. So adjacent of the 60 degrees, so that's 12, the hypotenuse is always double that, so this will be 24. And then the side length adjacent to the 30 degrees would be 12 times the square root of 3. And then here we have a triangle with 45 degrees and side length 8. If you see 145, it automatically means this other one's going to be 45. So if one leg is 8, the other leg is also 8, and the hypotenuse would be 8 times the square root of 2. So these special triangles, you will need to memorize those special side lengths. There's your full video on solving the triangle using Trig. Good luck.